Okay, so 10.8, we call these the power theorems, power meaning multiplication. So chord power theorems, here's the actual theorem. If two chords of a circle intersect, so remember a chord goes from one point on a circle to the point across from it. So you have two chords that intersect. The two pieces of one chord multiplied are equal to the two pieces of the other chord multiplied. So this is what it means. Let's put some points in here, namely A, B, C, D, and E. When you multiply the two pieces of one of the chords, so AB times BC, that's going to be equal to when you multiply the two pieces of the other chord, DB times BE. Okay, if you were to actually put numbers in here, AB is 8 times X, and that would be equal to 3 times 6. Okay, so 8X is equal to 18 divided by 8. X is equal to, what is it, 9/4 or 2.25. Okay, 2 1/4. That is the chord power theorem. Again, two pieces of one chord multiplied are equal to two pieces of the other chord multiplied. Now the other two theorems are the secant power theorem and the tangent secant power theorem. To me, they're the same thing. So what you do is you take the whole secant, okay, and multiply it by the external part. Then you take the whole secant and you multiply it by the external part. And essentially those are going to be equal to each other. So the whole secant, and right here, that's where that awkward 8 is, it represents the whole secant. So the whole secant times the part sticking out is equal to the whole secant times the part sticking out. Okay, so 40 equals 10x, x equals 4. So this little part sticking out is 4, which makes this little piece over here 6. Again, the whole secant times the part sticking out equals the whole thing times the part. So whole times part equals whole times part. Same thing with the tangent secant, okay? So it's the whole thing times the part sticking out is equal to the whole thing times the part sticking out. The only difference is the whole thing and the part sticking out here is the same. Okay, so but to me it's I would say it's the same thing. So I would do the whole thing, which is 9, times the part sticking out, which is x, is equal to the whole thing, which is 6, times the part sticking out, which is 6. Okay, and that's where the tangent squared comes in, right here. Okay, but to me it's the whole thing times the part sticking out equals the whole thing times the part sticking out. I just remember these as the same thing. Okay, so once again, x is equal to 4. And that's how you would do either the tangent secant or the secant power theorem. To practice down here, I gave you guys some examples. Again, so this is chord. If you'd like to pause this here and try these examples and then check to make sure you did them correctly, that's my advice. Okay, so once again, we have the part times the part is equal to, go the opposite way, the part times the part. Watch how I would solve this. I personally would just divide by 3. So x is equal to, I know that 9 divided by 3 is 3, and my answer there is 15. Okay, if you want to do 5 times 9, which is 45, and divided by 3, you get the same answer. I'm just taking the step out of actually multiplying the numbers, which is beneficial if you have some large numbers, and this is on the SAT, and you don't have a calculator. Okay, so let's go ahead and work on this one. So the whole thing times the part sticking out, whole thing times the part sticking out is equal to the whole thing times the part sticking out. Okay, it just so happens that those are the same. Whole thing times the part sticking out. Again, divide by 5. comes at 2. X is 20. 10 times 10 is 100, divided by 5 is 20. Same thing. Whole thing times the part sticking out. Okay. In this case, I believe the X is representing the whole thing. The 10, however, is just representing that little piece. So you guys are going to see what I do here. Okay, so the whole thing is X times the 3, which is the part sticking out, equal to the whole thing, which is 15, times the part sticking out, which is 5. Okay, again, watch. When I divide by 3, I would divide this by 3, and so I know X is 25. Again, to me, that's just easier. Okay. For the last one, it's asking me to find the radius of the circle. Okay, so now we actually have to do some math here. Whole thing, which is 10, times the part sticking out, 6, is equal to the whole thing, and I'm going to call the whole thing here X. Okay, so X represents the whole thing, times the part sticking out, which is 5. Okay, divide by 5, divide by 5. X is equal to 12. That's the whole piece. So this whole blue piece is 12. In order for me to get this pink piece, I have to subtract. So the whole blue piece is 12. I'm going to take this 5 away, so I know that this pink piece is 7. Once I know that this pink piece is 7, then I can find the radius. The 7 represents the diameter, so the radius of the circle would be 3.5.